Hi, and welcome. Let me make sure I get this correct. Now, I could have had a video. You'll see there's a picture there of that's from the Seattle World's Fair promo video in 1962 that you can see on YouTube. It's kind of fun. The question here is my background is not search. I've not done search and discovery that much. I come from the modeling side of the house, complex, fit for purpose models. And the question here is why, when you're looking at information fusion, what's bringing you to search, and then why is something as simple as a information pipeline down here? Why does that matter, and why is that structured? And we're going to go through. I'll give you the simple answer now. So we're going to have a 5-minute version of this talk, and then we'll go in deep dive. Basically, this picture here is of the 1-ton nail problem, which is during Soviet central planning. They asked for this factory to make 3 tons of nails. And they have, the story is they made one 1-ton nail, which got them very close to their targets. Apparently, it's in the yard as kind of an ode to central planning. But one of the reasons information fusion really requires rigor and flexibility. You have to know the units you're talking about, and we really don't have time for those types of mistakes. So why do you need pipelines? Because you don't want to end up with a 1-ton nail. So we are going to discuss, there's a further discussion on a website that I work on. And what I'm going to do now is just to give you a sense of how much information you may be doing. I'm going to do the quick run through of the deck, which I generally like to do. And this is just going to flip through. We've got words. We've got more words, quote. That's a picture of somebody jumping up and down. That's me when people go, well, I don't need your modeling tool. I can just use Elasticsearch or OpenSearch. This is a bunch of diagrams, how we're going to fusion. This is some blobs of color, but they're different types of search engines and different usages. I've been in a very environments where there are huge numbers of indices. And I think with OpenSearch, you can start to generate new indices, and that's part of this discussion. This is a high-level graphs, what is expected to be, and we'll drill into that if you're into graphs. Further on the graphs, another diagram with lots of cool kind of graphics if you're into that. There is a fuse and use. These are sample cases that you can drill down further. There is Star Wars fiction on there if you caught that quickly enough. I am wearing a Star Wars shirt. Here's some front ends, going from front ends for the information needs. And those of you who were just in the keynote, they were talking about that as a central concept. This is coming from not just unstructured information needs. There are a lot of structures, but they don't communicate well together, and that's why you need pipelines. So there's 3 types of front ends. A merger and acquisition case, what a pipeline can do to help with that. Enforcing conditions, this is the telemetry data, which is what really impressed me with OpenSearch, how they're working that. This is an information integrity, which maps some of the kind of mapping models we've been dealing with, entity stores. And then finally, what pipeline propagation might look like. Key lessons, and yes, that is also a picture of Elvis, which had to find its way in here. Elvis was at the World's Fair in Seattle in 1962. I figured since I'm coming here, that is a picture of him making a movie that I haven't seen. It's supposed to be one of his worst movies. It's Elvis at the World's Fair. Okay, so that was a 4-minute overview. Now the question is, this talk probably hasn't fused yet in your mind, but at least you've gotten the, I guess, a vector summary of it. All right, so back to why pipelines, and this is born of just experience of seeing what you think is a very elegant model fail just because the information coming in is very dirty. And I appreciate the pipelines as a very simple buffer and processor, but off of that processor, you can start to layer these things on top of each other, as was discussed in some of the conversational models, and they can really help you extract from other indices. So now that you guys have kind of seen the slides, if anybody has any questions, I've got a light that's kind of hard to move around, but we can go and deep dive on what's going to be your information needs. Let me start by how I got to Elasticsearch and OpenSearch. And a lot of this is just from although I've been interested in models, I've been very interested in mining actual metrics information. That was something when I started in IT was my main role, rolling up information just about how folks were using things, where do you invest in the future. And it's very hard to get that information effectively in a format where you can answer questions from leaders. It's like, does this data really mean that? And so the pipelines here, we're going to look at 4 areas where they really can help things work. One is securing access control, structuring data for downstream consumption, and maintaining information integrity and entity relationships. That's been a big one on the systems that I've seen and have had to support, and robust enterprise management. One of the confessions here, and I thought this talk could easily be called Confessions of a Formal Modeler. The last time I was in Seattle, it was an object management group conference. This one is much more fun. The failures are the models are actually tightly coupled, and a lot of people in the modeling business are also trying to sell a specific tool. And what happens is their information flows get locked into the constructs of that tool. And a lot of times the thought is, let's make a super ETL pipeline. But that also is not all that flexible. And much to the surprise, earlier Elasticsearch and then OpenSearch is really the legacy to that in my vertical. It has a key role to do that practical information fusion that users are looking for. And so I was in a discussion about whether we should have an enterprise architecture tool. And one of the clients, a person very suave technically, says, well, rather than having an enterprise architecture tool, why don't I just throw all of this Java doc and system documentation and my manifest, let me put it into Elasticsearch and we'll query on that. And my bet is we'll get more use out of that than having it in Sparks or one of these other tools. And I thought about that, and really the type of feedback you get and the type of reluctance you get for modeling information, the information's super usable. In the sense that you're capturing a lot of data that's really important about the enterprise, but there's no easy way to serve it up. The models themselves get locked into particular formats, variants of UML. And so one of the things that the recognition came is these models that may be very specific to a certain problem set need to be able to pipe out to some sort of search engine. And it makes very little sense to embed that in them. And so it was very easy for me to go, well, Elasticsearch, that's for just going out and finding what's on the internet. There were limitations to search, which is you couldn't create easily common views needed to describe the system. They weren't supported. So if you need to do a system view that understands dependencies, you could build that in your architecture tool. And search wouldn't do that. You can't really handle time and version questions. You can't answer questions related to complex entities, dependencies, and relationships, or so I thought. I've seen people do some amazing things in Elasticsearch. You can set up JSON models. They can be reflections of models. They can start to be tracked that way. So what I've recognized and why I've come to OpenSearch is those limitations of not being able to talk about accurate models and accurate information, those are things to be overcome. And you need a facility to make it easy to track and monitor the state of those specific entities that you have. And so pipelines can help create these managed data exchanges if the enterprise knows how to use them. So this is a picture of jumping up and down. No, OpenSearch won't work. So what would this look like? This is one of the massive eye charts that is very easy for the modeling community to come up with. On the left side here, you've got your structured and unstructured data. The structured data is in a lot of different formats. One example, a typical company, like just something as easy as a community college or a hospital will have masses of different data structures and information structures. And there's all sorts of security, HIPAA rules that get into those types of things. You also have got potentially link charts or community charts. That's what that big hairball up there in the corner is, which is generated out of a tool called Aura, Organizational Risk Analysis. That's to make as dense of a network cluster as I could. But you can do algorithms to query that cluster and pull networks out, and then you would pipe that into another index, basically. And what we found is that the fusion models alone are going to make category mistakes. That Soviet one-ton nail, you can get the everything is a cat AI problem. You can get the Zune, which Microsoft thought would replace the iPhone, the Maginot line, and just a failure to see change. So that's why the decision and action, the info infusion with models, needs to be able to be both observable but also flexible. The section 2. Section 1 is just explained why, if you're looking at models and you're wanting models to be used, why you need to start looking at OpenSearch. You're not going to just want to create one master index, which will be a lot of muddy stuff. You're going to want to have multiple indexes and think about how the pipelines are moving into your different types of indices. So what this looks at different types of search indices, grouping them so that you can talk about where you are in the search landscape. What does the information need? And that's what we heard talked about in the keynote today. And the way I've broken this down is if your interest is in fusion of information, you are going to start to layer the types of search indices you're using and the types of rules for the data you put in. Now, Fusion users actually do want a conversation. I think that's very true. I think the search community is seeing that with ChatGPT. And they also want access control, data quality, and clarity are their main information. And all of these require pipelines, but it really, pipelines are a necessary or a sufficient condition. It doesn't make what flows in them accurate. But speed requirements are the things that I think a lot of the high-end fusion models miss, because you can't, if somebody needs an answer, in a minute, they're not going to wait for 5 or 10 minutes for a bunch of processing or for human-in-the-loop processing. All right, so the 4 types of information kind of structures that I've seen OpenSearch used for are as follows. First is find, and this is very much the type of information flow that one would typically associate with search engines. It's a generic operating system dashboard would be an example of your UI. The content is coarse-grained. You have generic, even federated search results is how you're going to talk across multiple instances. It's basically an answer like, what information can I get here? What's here? What does it tell me about a cat? The next information need is managed, and typically this is less where OpenSearch has played, but I think you're going to see an ability, much as the discussion we heard today about conversations with your enterprise data. This is interfaces to the managed data is going to become important for OpenSearch. This is where your application's database and report centered. So even a moderate-sized enterprise, but certainly Fortune 500, will have dozens of different reports, data reports. A lot of times it's managed in Excel. They've moved to accounting systems, but none of that information is there it is mostly dark. So this will answer questions like, what do I have about item X? How much money did I spend on X? But it's not fused to anything else. Then there's discovery, which has been where this would be a dashboard, multiple graphs and visualizations. You're seeing this a lot in the observability work that OpenSearch is doing. You're going to have algorithms, output, monitoring. It answers questions like, what correlates to my employees leaving? Can I figure out any sort of information patterns that are in there? And then finally, fuse and use would be your executive dashboards. There are things here like the Tableau or types of UI structures that will let you pipe in information from a lot of sources. This is allowing you to answer questions like, what are key ways I'm going to retain staff? What would be steps I could take that would address what's being shown there? And type of conclusions are like, company I was with said, we're 50% more likely to retain staff if they have a close friend in their same division. So they did this big effort to try to get you to make friends with people in your own division, which to me was like a misreading decision because it just kind of seemed stilted. But those are the types of questions that end up getting answered, turning into programs, which would then be evaluated. So here's where, from a technical standpoint, that I've learned looking at all of these indices is a lot of cases, those 4 types of search problems, they all were going to have different types of tooling to them, right? So your one on the left, your basic info, that's your OpenSearch, Elasticsearch. Your official repos, that's going to be your PeopleSoft, your accounting systems. Your middle thing, that's going to be data scientists. You're going to pipe it out to Python. You're going to work there. And then your decision makers, well, they're going to have like a Tableau dashboard or Excel or email. But what's actually happening is these different types of paradigms are starting to merge together at these different levels. So even on basic info, you begin to see data science creeping into getting a better search result for a user. On the flip side, for the decision makers, they not only want to be able to drill into what a data science pattern is, they also want to be able to search whatever corpus was used to generate that information. And they also want to be able to see how that aligns with their official repository. So when you've got a world like this, you've got to get better at talking between these types of features. And I think OpenSearch, for a lot of reasons, is very well suited to participate as a member in all of these search and discovery type missions. All right, so drilling into more, these are user types, as we talked about, that they really do. The users of the index do help shape the environment, and you are going to get different index types. So your data science or decision making will have more emphasis on input structures, or maybe even I've seen folks do specific JSON templates that they're going to want to check for on the fly, so they can change that JSON template if there's some type of structure that they want to do. And then you can also do access control for the executives pretty easily without in keeping least privileged user approaches with the security plugin. All right, so this is a cartoon version that actually has some of the types of data sources that we talked through earlier, which is your find data. That's going to be, could be video data with embedded big text pools, log data, emails, your structured, your personnel databases. They could be RDBMSs, media, GIS, a lot of specialized targeted data sets that folks are using. I personally am interested in working the fusion model place is where my expertise is. But even there, when the performance comes in on the fusion models, it requires us to have that ability to pipe or use an enterprise vector database like OpenSearch. All right, so then some of the sample cases that I would bring out, the types of workflows and why flexibility needs to stay at the heart of OpenSearch here. One is an IT decision maker looking at where to put a data center. These are some of the information needs that I have seen. You're going to look at your EA framework. You're going to look at your development costs, location, personnel. So your analytics are going to have a fairly robust trail to them. You're going to have some formats that you're going to help make you make that decision. But to do that, you're going to have managed data, which is your configuration management system, performance reviews, HR. And you're also going to want to go out and find, are there industry benchmarks, external area assessments, things that can inform that decision. I'm not going to spend a lot of time on the others. I do have the Evil Empire. The info need there is the location of the rebel base. And that's going to be your analytics, trade routes, predicted targets, possible locations. Data, you're going to have prisoner interrogations. I think Princess Leia gave up the rebel base in Star Wars. and then also Rebel News reports. But there are a lot of information needs or key long-term questions, and I like the way in the keynote it was presented that there really is an intelligence analyst kind of phase to it that takes months of data prep. And in those types of cases, they don't know when they start what data they're going to need. So you cannot approach this as creating the Uber model up front. It's going to be generalized models. They're going to reuse what they have, and they want abilities to apply those models on the fly. All right, so 3 examples kind of pipelines that work, and went into some of the pipeline code, not with not on any enterprise scale, but on Docker, just to see how it would work. And there are 3 front ends to start from. One, this first one is a user access. This was from a project where each of those nodes that you saw were a different permission boundary for different user groups, and it all rolled together to become kind of a common operating picture. The next one, that's actually from the OpenSearch documentation. That's their OpenTelemetry front end. But drilling into that, there are a lot of the features, the way pipelines are being used by OpenTelemetry is a good example, and perhaps can be generalized into how to enforce expected structures coming in without slowing down your usability. And then finally, this last one is a consolidated entity and network view. That's an effort to also have like a graph database or a time series database, tracks, entities, a lot of information known about some objects coupled with data search algorithms. And all of those can use pipelines. So the info needs, I'm going to go through 3 cases here. The first is access control for a merger and acquisition phase, just how you might use pipelines. And this was due diligence review. So you're going to have a team up front. They've been given official legal sanction to look at documents between 2 companies that may merge. They're not supposed to share them outside. That sits in there. They need an access key to get there. There's going to be some access to company A and B data, but nobody wants to give the due diligence data team access to all of that. So the recommendation here is to mine company A and B data, pipe it into the new index, which would be the M&A information. You'd also use your dead letter queue and S3 for anything that would fail that type of translation. That would then give the due diligence team rapid ability to search and find how that would work. This is inside your prep pipeline. You could, down there, kind of covered by the red, but that's you basically sync output based on the conditions out to your S3 bucket. So it's a pretty easy way for any of these translations when you're in, I need a subset of this database or index, subset of this index, set a rule, pipe out your failures, and then your successes will be in your OpenSearch cluster. That one was able to do with a very simple data on Docker. The next one is enforcing condition on data. This is a telemetry use case. What this adds is the extra log structure processors, what the pipelines have added to them. If you look at the conditions of the pipelines, you're looking at certain structures of the courses. So the telemetry raw pipeline is here, the condition pipeline. You're going to have a processor for each pipeline reference, and this is the OpenTelemetry trace raw. But this can be set up for any type of structured output that you want. And this is how you can enforce, in this case, it's from logs, but it really could be from any data. This is how you would set that pipeline up, and they can become pretty quickly rather complicated building blocks, which is why I really like what was done here with OTel. You're calling out to some other standard so that if that were to change, you know which pipelines to change through a pretty simple code search. And then information integrity. This is This is one that starts to bring more sophisticated models into use. And in this case, unlike the logs, you're actually looking to pull entities out of your different stores. Here's the information need. You're going to want to see when you're doing M&A due diligence, is there any conflict of interest against, let's say, a known watch list? Are there any people who were a part of any decision-making process or belong to certain companies within a certain time series? So that would be the type of question you're getting at. You could go directly to all of these and try to get that, but the fact is it's going to be littered across a number of different tools, and you only have a few people who can actually see that rolled up data. So you could pipe out of the entity store, process in your entity correlation, and then apply diffusion models that the real burden here would be the fusion models would need to start to write in a form where they can take the pipeline and have almost in JSON is what you could do this in. Create a JSON template that says this is my model for this specific conflict of interest use case. You would then pipe that out to the protected index. Then you would have a decision maker do the info review. Now that may sound, I mean, there's a lot of different working pieces there, but what this recommendation is the information fusion teams should not obsess about exporting all of that data. Think about piping it from an index potentially, thinking about piping it into an index. You're going to have your graph network database, your time series data, things like Amazon Neptune. When you use those, they also, in talking with them, when they've got a certain question that's really a analytic text series or vector database question, let's use OpenSearch. Let's make sure your graph queries are being used for your graph query questions. But then out of them, that would be where you would get some of your time analytics. You would still be able to use and drill back to specific elements. So anyway, that's the processor grok match that's used for a lot of these is the type of the type of information I would expect to be in the pipeline. All right, so where does it get us in these three types of examples? And I'm sure folks will come up with other ones as they see. Is there's going to be utilities on the pipelines, but they shouldn't make the pipelines. I think their advantage is they're just a pipe. Much as you will see pipes can carry water, they can carry hot water. If you go and look over in the East Coast, you can go to Newport and the mansions there, they'd have their own extra pipelines to pipe seawater in. Why would you want to do that? People wanted to take seawater baths, but you don't want to get those confused. You don't want to pipe seawater into an open water. So the configuration management on the pipelines, the type of pipelines will have to be rigorous, but the pipelines themselves, maybe sizing up or different hooks into them would be helpful. But I think the system really is going to rely on a lot of external standards where feasible, such as OpenTelemetry. And you're going to want validation guidelines built into all of those pipelines. And they should be granular and easy to isolate so you can update them. So the key lessons here, it's the validation and the pre-processing. And it's the fact that really future technology is often unexpected. The power that OpenSearch brings and the power of vector databases and the growth of conversational search does mean you're going to see a vision where a lot of these things are going to work more seamlessly, mostly because nobody wants to spend a lot of time manually scooping data, well, not, going from one of these different databases to another. Getting them piped up for information needs is going to be where fusion modelers are going to be increasingly realizing they need to go. So, thank you.